Hi everyone. I've unfortunately allowed this project to become a little bit messy, so I'd like to spend some time just straightening things out a bit. Now, my main concern at the moment is with the map generator class, because this is currently doing three completely different tasks. First of all, it's allowing us to preview the map in the editor. Then, secondly, it's got all these methods for requesting map and mesh data on separate threads. And thirdly, it is generating the map data by fetching the noise map and then applying a fall-off map. So ultimately, I'd like to move each of these tasks into their own class and then get rid of the map generator class. Now, I can't do all of this in just this one episode, but I'd like to make a start by moving the generation of the map data from the map generator class into a new class called the height map generator. Now, if we look at this map data object, it's this struct down here, which currently just contains a 2D float array called the height map. Now, this isn't really the height map because later on in the mesh generator, we're still applying the height curve and the height multiplier to get the final height value. So it doesn't really make sense to do that here. I'd rather have that done in the height map generator class and have the height that the mesh generator is given be the actual final height. So I'm going to rename map data to be height map, since that's just a more accurate definition for what it is. And I'm going to rename this 2D float to simply values, and I'll rename that in the constructor as well. And this is going to have two additional read-only float values, a min value and a max value. All right, and these can just be added to the constructor as well. Float min value, float max value, and then we'll, of course, assign these. So this dot min value is equal to the given min value, and this dot max value, of course, equal to the given max value. All right, I'm now going to cut the height map out of the map generator file, and in Unity, I'm going to create a new C# script called the height map generator. And I will open that up. So this will be a public static class, so it won't inherit from mono behavior. And just at the bottom of the file here, I'm going to paste in the height map struct. Now the height map generator class is going to have a public static method returning a height map object, and I'll call this generate height map. And this can take in an integer for the width and height of the height map. And then it's also going to take in an object called height map settings. And I'll simply call that settings. Now I want this height map settings object to contain the variables for the noise settings. So those are things like the octaves, the lacunarity persistence, and so forth. And then it should also contain the fall-off settings, which currently is just a single bool, which is whether or not to use fall-off. And then also things like the height multiplier and the height curve. So I'm going to go over here into the data script, and I'm going to take this noise data class and rename it to height map settings. So this is going to contain not just the noise variables, but it's also going to steal some of the variables from the terrain data scriptable object, in particular the use falloff, the mesh height multiplier, and the mesh height curve. And then should also grab these min height and max height accessors. So I'll just cut those all out of there and paste these into the height map settings. And can get rid of uniform scale here. All right, and I'm going to rename mesh height multiplier to simply height multiplier, since it's no longer got anything to do with the mesh really. And then I'll also rename mesh height curve to simply height curve. Now, just to organize this a little bit better, I'd like to take all of these noise settings and put them in their own noise settings class. So I'm just going to cut those out, and then here we'll have a noise settings object called the noise settings, which should of course be public. And then in the noise file, down at the bottom here, I'll create a public noise settings class and just paste all of these variables in here. And this should be serializable, so it can show up in the inspector. And just like to rename noise scale to scale. The noise seems a bit redundant since it's part of the noise settings after all. And then I'll just quickly give these some default values. So I'll give scale value of 50, octave 6, persistence maybe 0.6, and 2 for lacunarity. All right. I'd also then like to have a public method called validate values. And this method is just going to make sure that all of these values are within a valid range. In particular, scale, octaves, and lacunarity must all be greater than 0. So I'll start by saying scale is equal to mathf.max, passing in scale and some small value close to 0, like 0.01 perhaps. So the max function will just choose whichever is greatest. So if scale is less than 0.01, then the value of scale will be set to 0.01. And can do the same thing with octaves. I'll set this equal to mathf.max of octaves and 1. So it has to be at least 1. And same thing with lacunarity. mathf.max between the lacunarity value and 1, and just make sure that persistence is between 0 and 1. So persistence is equal to mathf.clamp01, passing in persistence. Okay, so now the generate noise map method is going to, instead of all of these different variables, it will just take in a single noise settings variable called settings. Now, of course, we have to add settings dot in front of each of these variables to access them. So settings dot, and I'll just copy that so this can go a little bit faster. Work through each of these. This is now happening in the validate values method, so we can remove that. And then over here, settings.octave, settings.scale, persistence, lacunarity, and finally the normalize mode. Now, I do want to add one last argument here, a vector to sample center, and when we're adding the offset here, I'm going to add sample center.x, and here I will subtract sample center.y. And that isn't really anything new, it's just that in the map generator, when we were generating the noise map, the sample center was being passed in here, and we were adding that on to the offset. So instead of doing it like that, it will now just be a separate argument. Okay, just while we're here, there are two quick things I also want to do. First of all, I want to remove this else here and make these two separate if statements, because as someone pointed out, the first noise height that we generate is going to be both the max height and the min height, so we should be able to set both of these values. The other thing is that if our normalize mode is set to global, then we can actually do this normalization inside of the main loop, and we only have to loop through all of the values again if we're using the local normalization. So I'm going to put this if statement over here. All right, and surround all of that, and then I'll cut these two lines out. So that's the global normalization. Let me just fix the indents here. All right. So I'll paste those in here, and we of course only want to do this if the settings.normalize mode is equal to normalize mode.global. All right. Can now save this, and let's head back to height map settings. So in the onValidate, we'll no longer be doing this here. We'll simply call noise settings.validate values. And then let's save this and save the terrain data and head back to our height map generator. So the first step in creating a height map is to generate the noise map. So we're also going to need to know the sample center here so that we can pass that into the generate noise map method. And we'll now create a 2D float array called the values, which is going to be equal to noise.generate noise map, passing in width and height. And then we want to pass in settings.noise settings, as well as the sample center. All right, we'll now want to loop through all of those values. So for int I equals 0, I less than width, and then a nested loop for int j equals 0, j less than the height. Now, we will eventually be applying the fall-off mapping here, but I'm actually going to just ignore the fall-off map for the moment, and we'll be re-implementing that when we do some cool stuff with fall-off maps in a later episode. For now, we can say values with an index of I, j gets multiplied by settings.heightCurve evaluated at the height value, so at values I, j. And we then want to multiply this as well by settings.heightMultiplier. Now, it's important to remember that this generate height map method may be called simultaneously from different threads. And the reason this could be a problem is that the animation curve has some optimizations which cause it to give incorrect values if accessed simultaneously. This is why in the mesh generator, when we're given the height curve over here, we actually created a local copy of it to be used. So we'll do the same thing over here. We'll create animation curve, and I'll call this the height curve underscore thread safe is equal to a new animation curve, passing in settings.heightCurve.keys. All right, and we'll use this one instead over here. All right, now to create our height map, we also need to know the min and max values. So let's keep track of those. I'll create a float min value, which starts off at the maximum possible value, and a float max value, which starts off at the minimum possible value. We can then say that if the value at index I, j is greater than the max value, then I'm going to set the max value equal to that value. And if values I, j is less than the min value, I will set min value equal to that value. All right, so at the end of this, we can return a new height map object, passing in our values array, our min value, and our max value. All right, now since we stole most of the terrain data's variables and put them in height map settings, this terrain data scriptable object is looking a little bit bare and not very useful. However, it would be nice to have a single place to store settings for our mesh. So I'm going to rename this to mesh. Oh, let me turn off my caps lock. Mesh settings. Yes, I want to overwrite the file. All right, so I'm going to rename uniform scale to mesh scale. And then this is also going to have variables to control the chunk size of the mesh. So that means that we're going to be grabbing all of these integers from the mesh generator. Those will now be stored nicely in our mesh settings. So that's the number of supported levels of detail and the number of supported chunk sizes and the actual supported chunk sizes themselves. Then from the map generator, I'm going to take these two variables here, the chunk size index and flat shaded chunk size index, and those will be stored in mesh settings as well. We can remove the mesh generator from there since these variables are now stored right over here. And then also going to want this map chunk size accessor. That should be stored in mesh settings. So you can see here we're returning an element from the supported chunk sizes array and then subtracting 1 from that. I'm going to rewrite this a little bit more compactly. So on a single line I can just write return an element from the supported chunk sizes array, and then the index depends on whether or not we're using flat shading. So we can have a ternary operator. If use flat shading, then I want to get the flat shaded chunk size index, otherwise just the regular chunk size index. All right, and then subtract 1 from that, and semicolon. So since the 3 values here are the same as the first 3 values here, I'm just using this array for both of them, so I can just delete that array actually. Now I want to rename this to just give it a slightly more informative name. We'll call it the number of vertices per line, and then just add a comment here to elaborate on that. It's specifically the number of vertices per line of a mesh rendered at the highest resolution, so of a mesh rendered with a level of detail equal to 0. And I also want to note that this number is going to include the 2 extra vertices that we create just for calculating the normals, but those 2 vertices aren't actually included in the final mesh. So I'm just going to write here includes the 2 extra vertices that are excluded from final mesh but used for calculating normals. Now previously we weren't including those in our count, so I'm going to add 2 onto here to make it not -1 but +1. Alright, I think it would then also be helpful to have a public float accessor called mesh world size, so we know just how much space the mesh takes up. So we can return the number of vertices per line. Now we want to subtract 1 from that, because you can imagine if we've got, say, a mesh with 3 vertices, and these are spaced evenly, so there's 1 unit between these 2 and 1 unit between these 2, then the width of this is just 2. 3 vertices, width of 2. So we subtract 1, but then we also want to subtract 2 for the vertices that aren't included in the mesh, since those don't affect the size, obviously. So we end up subtracting 3, and then multiplying this by the mesh scale. Okay, so to now get this all working, let's head into the mesh generator, and I'm going to remove height multiplier and height curve from the arguments here. I'm also going to remove flat shading, and I'm going to add a mesh settings object called mesh settings. Now, you might wonder why level of detail isn't a part of the mesh settings, and the reason for this is that while technically we are generating a new mesh for each different level of detail, conceptually I like to think of it as not different meshes, but rather the same mesh rendered at different resolutions. So I think it makes sense to say that those different meshes all use the same mesh settings object, since conceptually they're actually the same mesh, and then this level of detail is just applied to say which resolution we want to render it at. I hope that makes some sort of convoluted sense anyway. Okay, now we can remove the height curve from here, and when we're getting the height, this is no longer doing any of this height curve.evaluate or multiplying by the height multiplier. Use flat shading is stored in mesh settings, so let's say mesh settings dot, and then to get the vertex position, we also now want to multiply by the mesh scale. Now, I don't want to multiply the height by the mesh scale. Since we have this independent height multiplier, I only want to multiply along the x and the z axes. So I'll just multiply here by mesh settings dot scale, and then going off the line a bit here, but over here, once again, mesh settings dot mesh scale. Okay, so that's everything for the mesh generator. You can save that and now head into the map generator, where we've got quite a lot of errors. First of all, I want to come down here and just delete the entire generate map data method. We no longer have a use for that. Then also, since we changed the map data to instead be called height map, I want to rename all of these variables that are called map data to height map. And similarly, all these things like map data thread should be height map thread. So I'm just going to do a find and replace all, searching for map data with a lowercase m and replacing with height map. So I'll just replace all of those. And then for the method names, I'll use capital map data and replace this with capital height map. Replace all 5 of those. Okay, let's now go up to the top here, and the height map settings shouldn't be called noise data. It should be renamed to, well, height map settings. And the mesh settings variable should be called mesh settings. Okay, now working through all of these, min height and max height are stored now in the height map settings. And by the way, this should actually be in a start method, not an awake method. I just found there's some error when it gets set too early in certain cases. Then over here, this is once again height map settings.min height, height map settings.max height, generate height map. This is in the height map generator class. And for the width, that will be mesh settings.number of vertices per line. And same for the height, number verts per line. And then we want to pass in the height map settings. So just pass in our height map settings object. And the sample center for the preview, we've just been using vector 2.0. All right, now we need to fix the generate terrain mesh parameters here. We no longer are passing in any of that. We're instead passing in a mesh settings object. And we can remove the use flat shading from there. Then the size of the fall-off map we want to create is mesh settings dot number of vertices per line. And over here, let me just copy this and paste that in there. Except instead of vector 2.0, we'll use the given sample center. And then over here, once again, just correct the terrain mesh parameters, so pass in mesh settings and remove the flat shading. Alright, so I think that's all the errors for the map generator class. Might have a few more coming from elsewhere. So in the endless terrain, we can see it's trying to get this chunk size from the map generator. Now, this chunk size we use for things like determining the number of chunks visible in the view distance, and we divide max view distance by the chunk size. Now, previously chunk size wasn't including the what was then called the uniform scale, what is now the mesh scale. So this wasn't actually completely accurate. So this time around, we're going to account for that. I'm going to make float. I'm going to rename chunk size to mesh world size. All right, so this will be equal to map generator dot mesh settings dot mesh world size. Now, this change does mean we have to change a few other things. First of all, when we get our viewer's position, we're no longer going to divide that by the mesh scale. And then coming down into the terrain chunk constructor, the size that it's taking in will now be a float for the mesh world size. All right, now this position variable, I want to rename that to sample center, since this is the point where we're sampling the noise. And this should not be affected by the mesh scale, so I'm going to divide this by map generator.mesh settings.mesh scale. All right, then I'm going to just move this line up here. I'm going to make this a vector2 position equal to coordinate multiplied by mesh world size, and the bounds will be centered at this position. And then when we want to set the mesh object's transform position, we'll just set this equal to a new vector 3 at position.x, 0 on the y-axis, and then position.y for the z-axis. And finally, we no longer need to set the scale of our mesh object, since the mesh scale is being actually baked into the mesh. Alright, so we can save this, and let's see if there are any other errors. So over here, the number of supported levels of detail is stored in mesh settings. So save that. And here, that's just the same thing. And then, before I forget, in the mesh generator, I made a mistake here when multiplying by the mesh scale. I need to just enclose all of this in parentheses so it all gets multiplied by that. And same thing here for the x-axis, like so. Okay, so I'll save that, go into Unity, and that should be all the errors sorted out. So now I'm just going to go onto the terrain assets. You can see these have lost their connection, so I'm just going to delete those. And I'll recreate them here. So new height map settings and a new mesh settings. And let me just assign these to the map generator. So that's the height map and the mesh settings. And let me just give this some sort of height curve. Add a key over there. Just something like that, I guess. And set the height multiplier to maybe 50 or so. Alright, I'll change the mesh scale down to 1 and bring the chunk size up. Okay, so let's clear this and see what happens if we generate. Alright, and the texture seems to have been lost, so I'll just update that. I also want to set the noise settings to global here. Alright, let me put this on auto update. Okay, I'm just going to toy with this a little bit more. And maybe just change the noise settings here, perhaps bring the persistence down a bit. Something like that. Alright, so on the map generator, I'm going to quickly test the different levels of detail, just make sure that that's working. Alright, and then on the endless terrain script, I'm just going to turn these settings down a bit, 200 and say 400, and I'll make my viewer object just this viewer here. I'm going to disable the rigid body for a moment, and before I hit play, I'm going to close this profiler window that I have open because there's a bug sometimes where having that open crashes Unity. So I'm going to press play now, and that's generated the map. And if I grab the viewer object and move that around, it should correctly spawn in the terrain chunks. So that is everything for this first part of the refactoring. There's still a fair amount I want to do, but I will save that for another episode. Until then, cheers.